Hello, I am Michael Gaucher, and it is February 12, 2025, and I have spent the last couple of days putting the finishing touches on a few functions that I built in C++ using GTKMM-4 in Linux. So this application is one that I started a few weeks ago, and it has rapidly accelerated into something that is a nice, neat, compact way to scan inventory, scan products, and scan a number of things. I will talk about that in this video where it concerns the file import function, and then there is a video that will come after this that deals with the file export function, including a discussion about EDI 856. First, let's do a demo of this program to see it in action. I've produced a software program that this week I added some new functions, and I have import and I have export. In the previous video, you saw the export option in the menu, but you saw that it didn't do anything. And I've added import, which may not be in the final version, but I wanted to put it in this development version because it helps me do a very useful thing. So you have to watch the previous videos to see how I use a handheld scanner to scan barcodes, that the barcodes stream all the way down here. But the thing is that even with scanning all of that, right, scanning it over and over and over again, that's going to get tiring in terms of testing. So what I did instead is I used my powers as a software developer, software architect, to speed this up. So what I did is I made a text file that has all the barcodes already in it, or the barcode values. And so when I open it, it's as if I scanned all of this, right? Which would have taken me like 30 minutes to scan this myself. This did in a second, right? And so there's about 228 barcodes, right? 228, not barcodes, 228 serial numbers in this file. And the file is set up in such a way where when I import it, it's going to run it through this, process in the same way as if I had scanned it, but it's doing it at machine speed. It's doing it at the speed of the computer. So that way it's much faster. And so I can go through test rounds much faster. And I know last time I talked about setting up this reset button. There it is. It's implemented. So the reset button is implemented. And the erase all is also implemented. So that's done. So then the next thing is I wanted to make sure I had the export, right? And when I export, it produces a file. Let's take a look at that file. So the configuration is currently set up to default to tab delimited. So this is what the tab delimited looks like. I can open it like this as a plain text file, and so each container has the serial numbers for that container affiliated with it, right? So I could do it that way. I can also open this with LibreOffice Calc, which is very similar to Microsoft Excel for those that use Excel on Microsoft Windows. And so just like Excel, it's going to open up the tab delimited into the proper columns and rows. So I also finished the function right close to midnight to also do EDI 856. So that's the 856 file. And I'm going to delete this so that when we go through the actual rounds of compile and testing, we can actually see that. But I wanted you to see the end result up front. This is the C++ application that I built on Linux for Linux to handle barcode scans that then can be applied to inventory, warehouse management, healthcare barcoding, retail etc. So let's get into it. This will be a walkthrough of the file import function in the program. Now that we've seen that this software application can generate an EDI 856 file, let's move this conversation to the actual software code, because that is where everything comes together. So I want to do a very fast recap, because the previous videos describe certain aspects of this software application, but for those that only catch this particular video, I'm going to do a fast forward up to the present moment, and then we're going to then take the conversation onto the file export, because that's really the main discussion that is taking place here is about file export. So first, I have a C++ application that's written on Linux, written for Linux primarily, and that is built using C++ and GTKMM-4. I've kept it simple. I kept most things streamlined, including the way the application starts up. The startup preamble is very simple. I am using an instance of Gaucher application, and so I'm using GlibMM, right? Which stands for GNU library, or GNOME library, I should say, GNOME library. And the GNOME library, which might as well be a GNU library, I mean, they work hand in hand, but the GNOME library is going to provide some high-level abstractions to make working in C++ and somewhat indirectly C work a lot better. And one of those is the use of the best practices in C++ that you can embrace without going so far over the edge that everything just breaks. And so what glib does is it provides a number of functions, and one of them is make reference pointer for instance. And what this does is it creates a smart pointer based off of the class or the class type that's provided here, right? And here's the actual instancing of this. So the object is actually created here, and then this is going to wrap that in a smart pointer. And you could just use an STL, standard template library, smart pointer directly. You could do that, but the advantage of doing it this way is GlibMM has its own smart pointer abstraction on top of that allows it to work more smoothly with all of the visual widgets that you are composing together in a GTK application. So we use the term GTK and GTKMM interchangeably. And we do so because GTKMM is merely a wrapper for GTK. So I've written 10 years of GTK software, 10 years of it. And I decided to use this wrapper in order to speed up my software development, because I have expertise in GTK, but I've reached a point where I want to do it in a more streamlined and a faster way. And so what this does is it allows me to have access to the RAII, I call it RAI. Resource acquisition is initialization concept in C++. Keep in mind, I use terms like that because we're keeping it to the basics. We're keeping it to the foundations, because that's how you achieve a certain level of mastery, and that's how you keep things sane and have things not go so overboard. And so when you have this smart pointer, right, as this application, then when this application exits, then all of this is going to get cleaned up automatically. And it's going to get cleaned up in a clean way, because there are messy ways to do cleanup. There are very messy ways to do cleanup, but we want to do cleanup in as streamlined a way as we can. right? Because as of this year, 2025, we are just about 75 years into structured software development since the NATO conference on software development that happened in the 1950s. So after about 75 years, you would think that we'd have things a little bit more buttoned up when it comes to building software applications. So that's what we're doing here, and that's the direction that we're taking. And so we use a function called make window and run, right? Which is going to take this main window type, it's going to instantiate it for us, and then it's going to make it visible while the application operates the message loop, right? So if any of that sounds foreign or sounds very unfamiliar, it's okay. It is really okay, because much of what I'm saying is what you would call at a lower level, right? Because I spent a significant amount of time studying the lower level ways that this could be built, and understanding those details has been useful in the past. But when we streamline things, right, it's nice to not have to engage those at this level, right? So what we want to do is look at the application. So this is Gaucher application, right? And what Gaucher application does, it's a class that inherits from GTK application. And like I said, GTK application maintains the loop. It maintains the loop that keeps the visual application active. Because any graphics programming that you do at a lower level, you do it in you start with a loop. It's a for loop, a while loop. It's any kind of loop you want, right? Usually it's going to be like a while loop, infinite while loop, but you can do variations on that. And that's the main thing that an application does for you when you're writing user interfaces, is it keeps that application up while the screen is being drawn and painted and presented visually. So we can build off of that, right? And so what I did is I decided to have the stubs in place for future expansion, right? So I'm going to make sure the actual startup sequence for the application is executed before I do my own startup sequence, right? And that is something that is required of you to do. You got to do that. In the constructor for this application instance, that's where I set the ID for the application. This is the most important line. All the rest of this is optional. This here I put in because I wanted to allow this application to have multiple instances. So if you don't do this, the default is it's a single instance application, wherein this ID is going to serve as a singleton, and it's going to constrain launches of the application to just one. So any subsequent launches, even if they have additional command line parameters, is still going to pipe through the actively running instance. So I didn't want that. I may change my mind on that later on, but for now it seemed like a good idea to have multiple instances of this application. So that's what that does. And then using a GTK application, it then uses the make window and run, because remember, we're inheriting ultimately from GTK application. So make window and run comes from GTK application. So what we're running is our main window, which is structured like so, right? It derives from application window. So it could have either derived from window or application window. I chose application window to ensure the best integration between the main window and the application itself. That's according to the GTKMM documents and documentation. So I have a header, and this strip up here is a header, right, in terms of the terminology. So when we run the application, this strip up here, this is a header. And then this right here is the menu. That's the menu. And so that's what we wanted to establish here. And then we got certain actions. And when these actions execute, then they're going to flow into certain functions that have been configured, right? And then you got the visual layout of the window itself. So the previous videos primarily concerned that. And then the next set of videos after that talked about the actual data going into the window, right? So I have a barcode list, which when each barcode is scanned, it's accumulated into this list type. And the list type has elements of barcode record. And so this is a barcode record. And the barcode record, all it does is it holds a single value. And you'd say that seems like a lot for just holding a value. I absolutely agree with that. But that is the requirements of GTKMM and the underlying GTK data model. So you have to work with the standards of the platform that you're using, and that's what is required. And so that's what the barcode record is. It ultimately holds the barcode, the scanned value of the barcode. And then I have a signal factory. This was suggested in the GTKMM website, GTK Programming with GTKMM website, which I made a PDF version of this. That's all described in the previous videos as well. And so I set up the signal factory. It really wasn't necessary, but I said, hey, let's go ahead and set up the signal factory. It seems like it's going to offer some performance benefits, which I think it does, right? But it's the only time I use the signal factory. I decided to make all the other signal usages one-to-one. And then I have the scan configuration window. The scan configuration window, it's very simple. It's laid out to simply hold configuration options. And so those are configuration options that can be changed while the application is running. And so you can toggle any of these options, right? And so anytime you go back in, there are those options, they're saved, right? So if we want to lengthen the scanner, or let's say we want 20 items per container, and then we want to make sure our barcodes are anywhere from 8 to 21 characters long. We can do that, and it would be saved. And so on subsequent accesses to the configuration window, there are our saved option values, right? And so that's basically how that operates. So that's the configuration window, and this is the implementation for it. And I basically just made it as a cycle. I made it as a cycle. So basically what happens is the main window is going to have this configuration data. So let's look at that a little bit. And yes, I simplified the constructor, and I simplified other aspects of the initialization. And again, all of this was this code here has been described in the previous videos. I haven't changed it, and there has been very little change to this. I may have added a menu option here, so I added a menu option and the appropriate the associated signal, right? And also have some cleanup code, because the GTKMM documentation does say that in some cases you don't have guarantees on the memory being reclaimed by the system or returned to the system. So in terms of automatic cleanup with smart pointers, it's still a prudent idea to explicitly declare a null pointer on exit. And so I made sure that I did that just as a prudent measure. And then the binding of the barcode field to its associated logical operations when a scan is taking place. That's also described in the previous videos, but the difference here is I kept the code sequence the same. I simply merged in this configuration record, right? So all the configuration data that we looked at, that's merged in. So I merged that in. So rather than hard code these values, it's now dynamically addressed through the configuration record, right? The configuration record is declared up here, and so that's the configuration data, and then the configuration window operates on this configuration data. So that's the cycle that I referred to, right? So let's look at that. So when we open the configuration window, one of the things that you'll notice is that it's very straightforward, and I talked about this in the video preceding this one. Let me make a statement here in this video that I'm going to make several times in this video because it's an underlying theme. But I started out with this documentation at the beginning of this process, but by the time I got to this point in the development of this program, I didn't need this document anymore. So this coding pattern is very similar to what you would do in Microsoft.NET, or you would do in Java, or you do in any number of platforms. And so I didn't need documentation for that. I didn't need tutorial documentation for that. What I started using far more is just dev help, right? And so I just went at it directly, and I saw where the patterns were going. This doesn't tell you how to use this. It doesn't tell you how to write all this code, and AI can't do it either. I didn't even try AI, right? By the time I got to this point, I wasn't attempting to use any AI. And so I just relied on my experience, and my experience paid off. And I was able to, it took me a good while to figure this out, but I was like, I've done this before. The pattern has to be the same. Well, it doesn't have to be the same, but it's like, that's the only thing that, when I didn't have because I did go in here and I looked at how this was done in here. I looked at the demo code like I talked about in the previous video, but nothing was really clicking. So I was like, okay, because I would set this up. Some of this I didn't have, but some of this, so when I click the configure menu option, I wouldn't actually see a window, or I would get to the point where I get this with the right sequence. So this is very, very key. Set hide on close. This is not a default. If you read the documentation, it's going to say that this value, true, is the default value for this function, which if you read the documentation a certain way, you would think that that's also the default it is automatically configured with, but that's not true. It's not set to hide on close by default. That is not the default. That is not the default. And since that is not the default, then what you end up with is when you close that window, then you don't get a corresponding signal that you can rely on, right? Okay, so then when I set hide on close to true, then this signal actually becomes active because I kept closing the window, but this would never run. And if this didn't run, I didn't get my configuration data. And if I didn't get my configuration data, then whatever I had declared as the default for the configuration record was all that the program was going to run with. Because these are the default values. That's all the program was going to run with. And no matter how much I changed the values in the visual part, so when I went up here and I activated the configure window, it didn't matter how many times I changed this. Every time I went back, it was as if I didn't change anything, right? So I could change this. I could change this. I could change that. And when I went back, none of that kept the values that I had modified, which threw a kink in the entire process. So by figuring out that I needed to do this with no additional help from anywhere, I was able to make this operate. But it required that I did a close reading of this document. And the way I did it was, I would just expand and I would just read through these and I would read through these. And I know that takes a while, but that's still faster than artificial intelligence. And I would just read through these and I would just start piecing together in my mind what parts should go together. And that's how I was able to actually build this up, by being able to interpret technical documentation. And you would go and you say, okay, what is this? And you would see this and you start to see a pattern. This. So anytime I saw this anywhere in the documentation, that was a note to me that, if I need this, I need to actually use this explicitly, right? That was a hint to me. Anytime I was going to use this, I said, okay, what is it returning? Is there any gotchas here? So I might spend like anywhere from 20 minutes to an hour just reading over this and letting it marinate in my mind before I was like, okay, now I'm ready to actually take action and do this. So that's how I put that together. And once I got one dialogue of working, then I was able to get other dialogues working, which it turned out it was good that I had that challenge with the configuration window, because later on when I needed to do the file export window and the file import window, and I actually built the import window first because I was like, you know what? No, actually, I wrote this code first, but it didn't make any sense when I started testing. I was like, you know what? I need test data. And I wasn't going to sit and scan all these barcodes. So then I wrote this. So then I was like, let me just do an import. Software developers do this all the time. We just put shortcuts in the software to make life a little easy for us, and it may not show up in the final version. So this is the rough cut. So I did import, and I studied the file filter because I knew from doing this same type of code in .NET, in Windows Forms, for example, Microsoft Windows Forms, it's the same kind of thing where you have to have kind of a filter for the file types that will be accepted when the open file dialog, open folder dialog is instantiated. So it's like, you know what? I bet there's something similar here based on what I'm reading in the documentation. And so lo and behold, I said, but I wanted to do it right the first time. I didn't want to go through multiple rounds with this. So I made sure to read the documentation thoroughly and then write the code, because I didn't want to do junior level code and then have to later on make it more sophisticated. I wanted to understand the more sophisticated approach first. So that's what this is. So if you're going to do a open file dialog where you want to filter it, as of GTKMM-4, this is one of the better ways to do it, right? Because you have to read the documentation carefully, because some things are deprecated, right? Some things are deprecated. And what I decided to do is use the FileChooserNative. A FileChooserNative is going to toggle behind the scenes between a file dialog that is made up entirely by GTK, or a dialog that is the natural dialog window on the operating system. And so I wanted that option to use the native dialog from the operating system, because that's going to give you the most security, that's going to give you the most performance, and that's going to give you the best consistent experience for those that are used to opening files through a window in the operating system that this happens to run on. And the other thing that this will do is, if this, now I haven't tested this, but this is my theory. Even in Linux, if I'm on a KDE desktop, this should make the open dialog more aligned with the dialog in a full KDE environment. Or if I'm on macOS, it's going to make the dialog look that way. So what I'm saying here is that when I go here and I say import, then this is a dialog, this entire window to open a file, right? When I go to open a file, right, this is the way it's supposed to look in a GNOME environment. But if I switched into a Microsoft Windows environment, this would look different in terms of the way the buttons the buttons look and everything else. And so if I don't do it this way, then when I run it on Windows or Mac OS, and I have no plans of doing so, but if I did, then if I didn't use this, then the dialog would not look natural. It would look more made up, which is not necessarily a bad thing. I just don't want to invest the time to create a custom file open dialog. I want to use the standard that's in operation on the system that I'm running, because that is more efficient at this moment. So then when you do this, you also have to determine what type of action you're going to take. In this case, I want to open a file. I don't want to open a directory. I want to open a file. And so I preset it with the home directory. So on a Linux system, you have a home directory. Because this code is supposed to be cross-platform, I would imagine that this would change to C Windows users, C users, and then your username, etc. on a Windows environment. I'm supposing. But because this software is optimized for Linux, I'm not really concerned with that, but I think this would be portable the way that it's written, the way that I wrote it. Then I set up the signal response, right? And then I also set up, so all of this can be done in any order. The order of this doesn't matter. It all has to be done before this line of code, right? Before you call show, you just got to get all of this set up. So anyway, I don't want this dialog to provide the ability to create folders, because that's not the objective of this dialog. It's supposed to be read-only. No multiple files, because we only want one file, one import file here. The allowed file type, which is files ending in .txt. We want this modal, so we want, when this dialog opens, then you will only use this dialog, and then if you don't want to use this dialog, you can click the close button or cancel. And we're going to make the window that it's opened from as the parent window, and then show. So that's how that works. So then once you choose a file, then this is the signal that's activated. And I found the documentation didn't explain this part very well. I just went ahead, just rolled with it. I said, okay, I know it says that you're going to get a response ID, right? In fact, let's go ahead and find that. So signal response is what that's called. So signal response, and then that's the slot prototype, right? So whatever function you're going to bind to this signal, it has to have this prototype, an integer. But this is a C++ framework that we're using. So instead of an integer, what would have been more appropriate would have been a classed enum, right? When you look in the C++ reference, let's go to the C++ reference. When you go to the C++ reference, right, let's see, enumerations. Let's find enumerations. Enumerations and enumerators. All right, so you got your unscoped enumerations, which has been the default in C++ since C++ has been around for the most part, right? And then you can have types with that since C++ 11, right? And then you can have what's called scoped enumerations, right? Or what I call class enumerations, right? Enum class, and then you have your type, which you can bind it to an integral type. You can do that, but in code you're going to refer to it the same way you would refer to enumerations in like Java or C# or somewhere like that. You're going to refer to it based on type name and then value, enumerated value. But I just thought it was interesting that they didn't do that, right? There were other oddities like that that I overcame. I had to use grep on the include files in the file system to figure out some of this stuff. But anyway, all right. So I just rolled with it. I said, okay, this should still resolve to the underlying integral value, and it should still correspond to the right operation, and it did. So I'm glad I didn't have to spend too much time on that. Then I get the actual file handle. It's a file handle. Understand that files in GTKMM and glib it's a hierarchical type system. It's a hierarchical object system. So you're not going to do something like you do in Microsoft.NET where it's a file get all lines or something like that, even though glib does have a utility for that. So let's see, let me open a new tab so I can keep my other ones up. So going to glib, file utilities, you can get all the file contents in a single line of code. That's pretty cool. But if you're dealing with a large file, you really don't want to do that, unless you got a good strategy for managing that. So generally speaking, this is a good function to always have. I've written it by hand in C for those moments where that I needed it. But in generally speaking, you really want to be careful with something like this, because depending on the size of the data that you have on the file system, this could work against you. But it's good to have that handy for small data that is small, and it's reliably small, and you just need to read it real quick and parse it and process it. But that's a convenience function, right? That's a convenience function. The actual file is just a handle, right? So it has many functions, and you have functions for reading, and notice that none of this is going to return back a string of data, right? You can go through this, and I spent a lot of time on this. It's not going to return a string of data. Any of the read functions, right? The ones that you say, oh yeah, I got a read function. That's your clue that you're dealing with a hierarchy. It's very much like the C++ STL in that way, to an extent. But so you got a file handle, and one of the convenience functions is query exists. I know the documentation in GTKMM says you really shouldn't use this, right? It says you shouldn't use this, and let's go to that. Here, let's go to that. Query exists. All right, query exists. Note in many cases it's a race condition to check for file existence and then execute based on that, because the file might have been created or removed between the operations. So what it's saying is, by the time I have checked that the file exists, by the time I get down here and I actually start doing things with it, by the time I get down here, the file could have been deleted. Okay, so how many seconds do it take between the time I check this and the file to be deleted for this to be invalid? That's the real thing. So what they're saying here is valid when we're talking about server software, and we're talking about certain types of software where you're dealing with files being created dynamically, and they could just as easily be removed at the same time. That's valid in that case. But in this particular case, where it's a single user on their desktop and they're looking at a file and they know that the file is not going to be deleted, and at the same time the length of time between this line and when this line starts running is probably less than a fraction of a second. Let's just say 40 milliseconds, right? Make sure I got that. Yeah, 40 milliseconds. Yeah, so let's say it's 40 milliseconds. You're not going to be able to click. You're not going to be able to click here, click here, click here, and then if I see this file, if I click open, you're not going to be able to click the open button and go to the directory where this is and delete it in a normal user sense. I mean, a software developer can contrive a script to do that, but a normal user is not going to click open and then this starts reading the file and walk over to the directory and delete it in the length of time it takes for this to actually finish. This will finish far sooner than it would take for the person to actually click on the directory and navigate to the even if they already have the directory open, and delete it. Even if you already had it open and you click and you tried to alt tab or click over to it, this will still finish before all of that in the majority of cases. So this remains a valid way to do that, right? So anyway, then you need a data input stream. See, you get a file stream when you start the read operation. So that's a file handle set up for reading, and then you need an input stream that can deal with the actual character data, because this only deals in bytes. So you can actually work off of the file input stream directly, but if you want string data, which is what we want in this particular case, then you need a data input stream. If you want an abstraction that's already put together that will make this work. And so this is code I've written hundreds of times, and so I know it like the back of my hand. And so anyway, it don't matter what programming language I'm dealing with, this is pretty much the same, anyway. So there you are. So we got that, and then I did the cleanup, and that's how the data is read. And so notice what I did. I call unbarcode activate. So notice what I'm doing. I'm setting the text in the barcode field. So when you scan, so let's say you scan, you went beep like that. Now, so that's setting the text. I got the text, and then the enter key is what puts it into the active scan list, right? Now, some programming environments, some frameworks, Windows Forms might do this, but I don't recall if it does or not. But if you put a line return in there, that would be the same as triggering an event like this. So I actually tried that at first. Then I had to go back and read the documentation. It's not going to be triggered off of a new line character, right? The scanner, the handheld scanner that I have, it sends a new line character that is interpreted as pressing the enter key, right? But when I set the text myself and I put a line return, right, it doesn't trigger that. So the GTKMM framework is very specific about that. So I decided, okay, I'm not going to try to see if I can trick it to do that. I'm just going to go ahead and set the text, and I'm going to call the event that would have normally activated on its own myself. So, and I think I would prefer that anyway, because I have more control over that. And here I set the text, it activates on that data. It runs, so unbarcode activate. That's the function that has all of the logic for dealing with the barcode and determining whether it's going to get included in the list of barcodes that have been successfully scanned, as well as building a container, right? So, and then I clear out the line data, because that's going to be more performant than doing a dozen different allocations, or at least we want to reduce the allocations a little bit. But we don't want to go too far with that, because we're not trying to prematurely optimize this thing, So anyway, but The performance is good on this and it runs smooth, and that's importing the file.